Hey there, guys. Sorry about that. I had a little bit of an issue getting things online. Welcome, welcome, welcome. It's What the Physics. Good to see you all. If you have your video off, that's okay. You can, especially it might help with the bandwidth issues. If you have trouble with audio, instead of using internet audio, you can use phone audio and use your phone as a phone call. It's just a phone call rather than any kind of data usage. So your audio can come through there, which is kind of nice. And then you can use earbuds and stuff. You don't have to worry about connecting to the Chromebook audio. That's kind of neat. Anyway, do try that out if you get a chance. Okay, so glad to be here. I'm glad to see you guys. Uh, for the for your management of your video and stuff like that, you can keep your video off. You can have it on. I prefer on because then I get to see you and I get to see your responses to whether I'm confusing you or not. I can look at your face and you're like, huh? It's like, okay, then I know. Then I know I better back up or slow down. Of course, as always, at the bottom right here is the participant list. You want to click on that, and that way you can see everyone that's going to show up. And you can you also see the yes, no, go slower, go faster buttons. Those things I pay attention to, especially when I start asking questions. For example, I'm going to ask one right now. You should have the Nearpod open, and I know it's a little tough switching back and forth. If you can figure out a way to have me, I'm not going to be sharing my screen, so my screen is not going to change sizes on you. You can kind of manipulate it to be on the side, or if you don't know how to do that, just know how to switch back and forth. But what you want to do right now is have the Nearpod open, and what I'm asking is, have you finished the matching activity that's right after it says Zoom link or something like that? Right after that should be a matching activity. Go ahead and try that out. It'll get you warmed up for today's activity. And when you are done with that, or you're done with as much as you want to with it, click on yes, and that will show up in my list over here. And then I can move on when I see most of us have done that. All right, you can always return to the Nearpod later and get that. Whenever I do those matching things, my expectation is that my little hint to you is once you have all the matches made, take notes on those matches, right? Whichever way makes sense to you. Today, we're going to be doing stuff. You can do it in the Nearpod. You have choices. You can do it on a Nearpod. You can do it in Google Slides. And you can also do it on paper and just transfer it over later. I prefer the Google Slides because that way I can quickly grade it through Classroom. Uh, but that's a little hard to draw on, especially with a touchpad and or even a touchscreen. It's still hard to draw shapes. So I put the Nearpad version of the same slides, and I'm talking about the multiple representations 2 that was posted yesterday. That's due at 7 tonight. So once you're done with this session, you can mark this one done and then go and tell me how you did the four problems and do the best you can with them. If you don't get it, that's okay. So I'm going to quiet up a little bit, just make sure you guys have a chance to do on the Nearpod the matching activity where you're matching position and velocity graphs together. All right, so do that. If you have questions for me, chat is the best way to do that. It's the fastest way, I think, and you can you can always ask me to repeat something. It'll show up on my screen so I can take care of it. All right, cool. Looks like you can also type in answers into the chat. So like if I ask like, is it going to the left or to the right, you can quickly type in chat. So you want to have that available for you somehow. I think you can dock the chat, but don't spend too much time trying to figure out like where to put that. Just know where the chat is so you can add to it when I ask. All right. Thanks again. I appreciate all of you, and I appreciate all the feedback that I've been getting. Hopefully, you got some feedback from me about how you did on the lab. But I said I was going to be quiet. Dang it. Okay. Okay. So now the weatherman stuff. Let's see if I can get it to work. Ah, all right. So if you haven't pinned my video, the question from Layla is, are we allowed to do the lesson on Nearpod? Right, the thing. If it's easy for you to draw with your finger, much easier for you. I got frustrated trying to draw the motion map with my finger because when I touch, it doesn't draw the dot. I have to like move my finger around to draw a dot. That was kind of annoying. But yeah, if you do it in the Nearpod, just tell me that you did it in the Nearpod so I know where to look for your stuff. If you decide that you want to do this by hand, right? You sketch all the graphs and everything. You want to do it by hand. Then you can take a picture with your Chromebook. Like, I'm done with it. Here's my page. Hold it up to the camera. Whoops. Hold it up to the camera and click done. And then, sorry, take a picture. My wires are being annoying right now. Okay. So you can take your picture, take a picture of what you did with your Chromebook camera. The reason why I would say your Chromebook camera is that it's not super high quality, which takes no time to upload, right? Whereas you do it with your phones, they have the beautiful camera. Everything's in like HD or 4K, and you're like, sweet, now I got to upload that. Awesome. That takes forever. So use your Chromebook cameras when you can and take pictures of stuff. So in other words, you can do it by hand, and then like say you do problem one by hand on a piece of paper, post that as an image on the slide, or attach it to your work. Right? You can attach documents to your work that way. Yeah, yeah. So I don't mean to be confusing. Like, what do you want us to do it in? Really, as long as I can get to it quickly through Classroom, and if it's a note saying that I have to go to the Nearpod, that's fine. I have to look at the Nearpod anyway. All right. So yeah, do it as however makes sense to you. Okay. Awesome. Again, this is all practice stuff, right? So I'll give you, great, I'm glad I answered your question. I'll give you some time to get this stuff down. We'll have a quiz on Friday, and that's going to tell me kind of where you are at on your own. And some of you already know, you're like, I'm going to be horrible at this quiz. Here's the cool thing about my quizzes. As you have noticed from the lab quiz that I give you feedback, then you're able to fix it and get a better grade. And that grade doesn't average, it just replaces. So my 1-0 system, it was kind of sucky at the beginning. My grades were like, everyone was like, I have an F. Like everyone had, yeah. So until you fix those things, you're like, oh, I only had to fix this 5-minute thing and I have 100%. Yep, that was the idea, that you can revise and resubmit. All right. Yes, that's the point, is that when you fix it, you learn. You learn from your mistakes. So I want you to make mistakes. I want you to be a little confused about stuff, but not to the point of tears. That's ridiculous, right? I saw some people were like, this is horrible. I don't know if it was in this class. It doesn't matter. But if it brings you that much pain, well, one, thank you, because it means you actually care. But two, it shouldn't go that far. You should contact me, okay? I am always by my computer as much as I can be. I mean, I have other stuff I have to take care of as well as class stuff, but I'm usually on the case, on the ball with my email and chats. And all it takes is usually me just popping in and say, hey, this is all you got to do here, okay? And boom, you got it. So here's a rule for you guys: never spend more than 10 minutes on anything if you're not making progress. If you're making a little bit of progress, you're like, I get excited. Oh, yes, I got this. I can do this. Then cool, keep going, right? It takes you long. If it takes you an hour to do something, cool, whatever. Hopefully it'll get faster next time. It shouldn't take you that long, but the idea is that if you're making progress, awesome. If you're sitting there not making progress for 5 to 10 minutes, you're not going to make any progress much after that. It's because you're missing something, missing some information. Maybe it's my fault. Maybe it's something you missed. But get me involved or one of your teammates, and we can help. Right? I can help you quickly. if we were in the classroom, we'd all be working on these big whiteboards. Let me show you what those whiteboards look like. These aren't small, right? These are big whiteboards. And we would draw with markers really quick. And then like, oh, we would see each other's work really fast and be able to change it and fix it. So all this stuff would go by pretty quick. But when you're doing it on your own, it's tough. I agree with you. All right. And I know there's like the video analysis was a lot of steps. And I thought the video would help, but it didn't help everyone. So that's why I put in the visual directions. I think that helped a lot. What I saw for the most part was that everyone had good data. There's a couple people that didn't quite have good data for some reason, one reason or another, but just contact me. We can do it together. That's fine. I want to make sure you know how to use that software so we can use it when we get into acceleration unit 3. Our next unit next week is forces. So that's cool. The way quizzes will work will be if you do a quiz and you don't like your score on one of the parts of it, you can redo that part. The way you do it is you're going to make your corrections. You're going to talk to me, make sure you understand it. And then I'm going to give you a slightly harder quiz on the same thing. So you can't get that quiz until you've talked to me and you understand it better. Why would I give you another quiz so you could just fail it again? That doesn't make sense, right? So yes, the idea is that you want to know. I can show velocity in many different ways. I can calculate a position based on the information from an equation. I didn't say that right, but it's in that little SPG tracker I gave you. I'll be revising that a little bit and making it look easier. But the idea is that as you check off things, those stay that grade. So you're just building up your grade until you have the end result. And it's really time and that you pour into it. You say like, you know what? I get it now. I don't want to redo that test. So I have 2 out of 3 on that same standard. I have an A right now. That's not really going to change my grade much, so I'm good. So you can make that decision, like decide like I don't want to fix that F back there. But really it's not an F. It just means that you didn't get it. But it shows up in PowerSchool as an F, which is dumb. But I'm trying to meet you halfway with that. I put some participation grades in to balance that out. But anyway, okay, let's start with prayer here. I think it's one of the slides on the Nearpod, which I thought I had open, but apparently not. Okay. I leave my station for one moment and it's all different. It's okay. Here we go. Sometimes I get I like telling you stuff. I want to share stuff with you, but I realize we can do that through a video, not through synchronous. Okay. So I'm going to take a look at what you guys have. Sweet. Awesome. Okay. You can follow along silently. Remember your responses, but you don't have to have your unmuted or anything like that. Let us remember that we are in the holy presence of God. Dear God, thank you for today, yesterday, and tomorrow. My family, my joys, and my sorrows. For all that made me stronger. Amen. St. John Baptist de La Salle, pray for us. St. Francis St. Dominic, pray for us. San Miguel, pray for us. Live Jesus in our hearts forever. As I've said before, I always put that little positive thing in the beginning of the Nearpod to kind of take a deep breath and think about something nice to get you in the right mode so you can have productive work. So hopefully this will work. There I am, Mr. Quiros. So, all right, I'm going to go ahead and clear what we got on the side here. And on the next slide in the Nearpod is a draw it. And it should look very similar to this, right? It's not going to be exactly the same. I actually gave you some extra information, like I gave you a scale on this side and a scale over here. and it's color coded because it's the same thing, right? This line right here is the same thing as this line right here. And then you have your position time graph, velocity graph. So the nice thing about the draw is that you have the ability to click on the marker and you can change the size, the shape of the marker. You can change the color. And then you can either draw with your touchscreen or your trackpad, or I prefer, pen and pen on a screen. But even a mouse is better than a trackpad. Some of you would argue that, but being able to connect a mouse and being able to draw. If you get the idea down on Nearpod or on paper, doesn't matter to me. The point is that you should understand at least half of these questions, or at least half of the questions, or half of all the questions. There we go. By the end. So here we're going to use a little chat here. Let's take a look at what it says up here. And you might not be able to read it on my screen, but it's on the Nearpod too. The object starts at a positive position, first moving slowly in the negative direction, then moving quickly in the negative direction. So I'm going to get up and move my body. I have my number line here. So I'm going to start somewhere positive. And the whole time, which way am I moving? Am I going to be moving to the right or to the left? Based on what it says in the text description, type it into the chat. Am I moving to the left or to the right? Okay. Now we have some people saying left, more people saying left than right. So on here on the number line, which way is positive? To the right. Which way is negative? To the left. According to the text, are we going in the positive direction or the negative direction? Are we going left or right? Still got some people saying left or right, but most people are saying left, and you are correct. I hate that. Okay, so yes, you are right. It's going left. Oh, wait, what? Yeah, we're going to the left. Okay, cool. So if I'm starting over here on the number line and I move this way at a constant pace, and then it says then quickly in the negative direction, I'm going to move faster. Right? So I'll reset. I started over here on the number line, and I need a lot of space that way so I can walk to the left the whole time. You can imagine if I were to take a picture of me every second, there'd be a picture of me like here. So I'll draw my picture, right? And then I'm going to draw my picture again. And then I draw my picture again. Every second, I'm moving over. And then I'm going to go faster. I'm actually going to go in 1 second from here to here. I'm going to circle my head. And then, I missed. And then right here. Okay. Do you see how these dots over here are closer together? And these dots over here are farther apart? What does that mean when the dots are closer together? Put it in the chat. What does it mean about the motion? Yeah, it is hard to dot with the Nearpod. I agree. It looks like we're getting it. Okay, so that means slower here. So what does this mean over here? What's happening here? Faster. Yeah. So if you are an animator, animators have to deal with physics all the time. They have to think in terms of this kind of stuff, real basic. Say, I want my character to move from here to here. They've got to hit certain marks at certain times. So they put their character here, they put their character over here, and they decide how much time is that going to take for, let's say, 2 seconds. So the character would move like that. And then over here, it moves faster. At some point, right, the character sped up, but that was so quick that we don't capture it here. From here to here, yes, it sped up, but that's it. We can't say that it sped up the whole time. It just sped up at time 4. So usually we just say it was moving this way and then it was moving this way. We don't say anything about speeding up, accelerating, or anything like that. We're not there yet. We have a constant pace to the left and then another constant pace to the left, but faster. And for the motion map, what I'm going to do is just put arrows connecting those dots. Yeah, and it's hard to draw the dots with the Nearpod. I hate that. I found that out today too. But the idea is that if you maybe make a little tiny circle or try to just do a bigger circle, this is where like the Nearpod's great to draw all the graphs, but not the motion map. It's easier to draw it on the slides. Okay, it started in a positive position. We started at the right. We started over here. We had a positive position. I think that's what you meant when you asked, why did we start at the left? We started at the right. And then you go to the left. All right. If I started over at 0 and then, oh, I'm going to the left, well, you're just going into negative position. That's fine, except my graph doesn't have negative position. So either redraw the graph or just shift everything over. All right. That's what I like about drawing on Google Slides is that they're all objects, so you can just shift it over. If you're drawing by hand, you just erase and move it over. Right? And I would erase the number line, keep the dots where they are, and just change where the number line is. So that's stuff you can do. Okay, great. I love the fact that you're using the chat to ask each other questions. Thank you for that. That's awesome. Okay, so there's my motion map. That's the hardest thing, I think, right here, because this one looks pretty easy. But as soon as you change direction, oh my gosh, what do we do now? Yeah, we're starting our next unit, but we're always going to come back and look at, we're going to be looking at forces next that make something move at a constant pace. So combinations of forces that allow something to move at a constant pace. And then we'll cycle back. Okay. We're going to cycle back when we talk about what happens when the forces are unbalanced, then we can't go a constant pace anymore. Okay. The question was, are we doing it on Nearpod or Google Slide? Whatever is easiest for you. And if you decide that Nearpod is awesome, or if you just want Nearpod to be like your notes, and then you can transfer it onto the Google Slide, that's totally up to you. Just let me know in a comment when you turn it in today. You could even do it on paper if you wanted to and take pictures of it and submit that as your answer for each one. All right. Not to be confusing. I'm just trying to say like, hey, you can do it however whatever makes sense to you. Cool bean. All right. So I'm going to translate this. This is time 0. That's right. I started my timer. When I look at my stopwatch says 0 when I start a race. Right? It doesn't say 1. It says 0. So I hit start, and I'm 1 second, I'm at 5, and at 2 seconds, I'm at 4, at 3 seconds, at 2, and at 4 seconds, I'm at 0. So I have 5 dots there, and that took 4 seconds on my stopwatch. So where did I start at time 0? 6. Then I moved to time 5, then I moved to 4, then I moved to 2, and then I moved to 0. Now watch what happens. That's my motion map right there. Except I drew it. You can't tell which way I drew it. If you were to turn off and turn back on and have these things here, you'd be like, well, which way is it going? That's where the time axis comes in. At time 0 is up here. It's a coordinate match. So this time, where is the object at? It's at 5. So these all start to move over to match up with where they actually are located in time and space. The next second was there, and the next second was there. Now I connect these. The first section was the same motion the whole time. The next section was a little bit different. You can see if I were to keep that same motion the first time. Oh, looks like something happened here. Hang on 1 second. Thank you. Technology, am I right? Okay, there we go. So you can see for the first 2 seconds, I'm going this constant pace in the negative direction, and then I'm going a faster pace, the steeper line. So you have, if I were to continue this pace, original pace, I would have, by the time this time came around, I'd still be behind back here somewhere. So we have a way to illustrate. This is the same illustration as this. It's just two different ways to show the same thing. Actually, three different ways because we have the text right up here. The neat thing is, this graph could have been drawn many different ways, but you would have the same properties. It would have a gentle slope in the beginning and then a steeper slope in the end, and they'd both be negative slopes. So angled downwards, in other words. So someone else could draw this, and that would work different times. So that's why it might be a little confusing, because someone might draw something slightly different than you, but you have the same idea. You have a negatively sloped line and then a steeper negative slope line. So any of those would work. It could be down here. It could be anywhere, as long as it has the same kind of properties. It doesn't have to have the same numbers. All right, I think that's what's most confusing, is that, well, I'm used to having numbers and stuff, and we have to be the same. It's like, this is not a math class where you have to have the exact same answer as the teacher. This should look similar to someone else's, but you're going to all be unique answers, but you'll be very similar. Okay. So now that we see that we did this, the same reason why we started to the right over here is the reason why we started to the left. At time 0, right, we're at 6. So we're up here at 6 because we said so. We could have started anywhere, but we don't have a lot of room if we start lower. That's all. It doesn't specifically say up here, right? It doesn't say where we started. It just says that we started positive. But that's a great question, Angel. We started to the right to make room for the left. Okay, good. All right. And it might make sense to you, but it might not to someone else, and that's fine. We're all learning this at different paces. Over here, let's look at the velocity time graph. The only thing I'm going to show you right now is right here is where the graphs change, right? At time 2, the graph is suddenly different. Constant pace and another constant pace. We had a constant pace here and then another constant pace here. What would that look like on the velocity time graph? So first of all, our graph's going to be flat because it's constant velocity. Anytime we look up the velocity, it's the same value every single second. That's what constant means. If I had constant position, I have constant position right now. I'm not moving. But if I have constant velocity, if the velocity is not 0, then I'm constantly moving either left or right, depending on what we decided was right positive. Usually is in math class, so we'll keep it that way, sure. Left is then negative because it's opposite the direction. That's all it really means. Positive is one way, negative is the opposite way. If we decide that positive, it means move forward, then negative would mean move backwards or go backwards. Go away from the camera, go towards the camera, it's positive. Go away from the camera is negative. We have complete control over that, and that's where it might be confusing, because two people can be talking about the same thing, but because they decided that their directions are different, they're talking, well, I said that was positive. Well, I said that was negative. Okay, that's fine. The general idea should be the same. Okay. Motion is relative. If people were on my left watching me walk this way, it would look like I'm moving to the left. People on my right looking at me would look like I'm moving to the right. So if I were to ask everyone in the classroom to tell me which way am I going, they'd both say both answers at the same time, because their perspective and their perspective is different. So we just have to define that. We have to be careful. We just have to be telling people, like, hey, positive direction is to the right from my point of view. Okay, cool. Thankfully, we all have the same point of view right now, so I can move to the right on the screen, and you can see me moving to the right on the screen. So back to the velocity graph. I have a positive or negative velocity here. What is that, a positive or negative slope? Cool. Are we getting it? Does it make sense? That's a negative slope. As we go forward in time, the position is lower on the axis. So we have a negative slope. Slope of the position time graph is velocity. So the value of that slope, it looks like I'm going down 2 and over 2. So that value is -1 for every 1. -1 meter for every 1 meter. 1 second, excuse me, sorry. There we go. So -1 meter over 1 second. -1 meter over 1 second. So next question. I have a flat line. It's going to be negative, so it's got to be below here. Comparatively, I have to put 2 lines. Do I put it closer to 0 or farther from 0? And why is it down here? Because it's negative, right? We're moving to the left, so this is negative, just means moving to the left. Do we put it close to 0 or farther from 0? Answer that question for the first part. We're going to put a flat line down below the 0 here. This is a number line that gives us velocities. These are positive velocities up here. These are negative velocities up down here. Where do we put that flat line? Close to 0 or far from 0? Answer in the chat to see what we get. What does that mean? Everyone's saying close so far. Closer to 0. All right. What does that mean in terms of our speed? Fast or slow? Now answer that one. Fast or slow? Closer to 0 means slower. Yes, awesome. Okay. Notice that we're not slowing down, right? It looks like our graph is going down, but we're not slowing down. We're going the same speed. In fact, we're speeding up momentarily. We get to speed up right there. And suddenly we are now at a faster pace. But notice it doesn't say speeds up. It just says going faster or more quickly. So we're not dealing with speeding up yet. That's later. But right now our graph is flat, and so it's down here. Where? Doesn't matter. Let me change the color on that. Okay. Now, where do I put the next flat line? Closer to 0, up here, or farther from 0 down below? Answer that in the chat. It looks like you guys are picking up what I'm putting down. Belower? That works for me. More below. I love the English language. Okay. So I know this graph stops at this moment here, but because I have this other part of the graph, I'm just going to go ahead and make it there. So I can see that this graph has a distance from 0 like that. I make a little arrow because that's telling me which way is it going and how big the arrow should be. Take a look at this over here. What? Okay. What doesn't matter is the fact that I continue past my position time graph. I should stop here because I don't know what it's happening after that. That's all I meant. As far as if you know how fast something's going, close to 0 means, on the velocity graph, closer to 0 means slower. So if I want to go slow in the positive direction, there's my graph right here. Farther from 0 on the velocity graph, right? Up here, we're talking about position. Farther from 0 means I'm just far away from some 0 that we called up. At the middle line, this line is 0 velocity. We're moving, if that makes sense. That's a great, you guys have great questions. Awesome. Yeah, we don't start at 0 velocity because we don't know what it said it was doing before this. It's like we cut to the person already moving, right? Or whatever it is. It's not like they say, okay, go, right? You don't see that in movies where the car is like stopped on the street and then moving. like they cut to a scene where a car's moving, the car's already moving. So that's kind of what we're seeing here. Yeah, great questions. That's what I love about synchronous stuff, is you can ask these questions and I can answer them. All right, check out the length of this arrow. The length of that one is twice as long as this one. We're going twice as fast, is what it's saying. And over here, sure enough, I went 1 meter, and then later I'm going 2 meters, twice as fast. So all of this information should start matching up there and there. I love my floating hand. Okay. I'm having fun with this scene, by the way. I hope you guys are too. I hope it's worth it. Yeah, this is done for number 1. All right, I'll step out of the way, and you can take a look at that. I'll figure this out, but at some point I should be able to take a snapshot of this and send it to you all so you can get it. But I can't do that now. Some of you can do the screenshot thing right now. I'd give you like a few more seconds. You can do a screenshot of my screen. If you haven't pinned my video, or if it's not big on your screen, make it big, take a screenshot, right? You do Control and then Windows switch key, and that should save it in your downloads automatically. A lot of my lessons are complicated because not only am I showing you physics, I'm also showing you how to use your computer and other things. So I'm sorry if that's a little confusing, but I'm trying to help you out with other classes too, not just mine. This graph right here, yeah, this is number 1 on your homework from the work I posted, right, for multiple representations too. Now, I was going to do breakout rooms, and if I messed up your screenshot, too bad. I'll have these posted for you later, okay? After 4 o'clock, they'll have them posted when I get home, and I can clean them up, put them up there. Let's look at the next one. It doesn't give us the written, it gives us the velocity graph. But wait, take a look. There's something similar between that velocity graph and this one. There's 2 lines, so there's 2 parts of the motion, and one part is slower and one part is faster. Can you see which one is slower? The first one or second one? Which one's slower? You can put that in the chat. Okay, good. It looks like we have a little bit of debate between first and second one. Remember, how do we tell if it's fast or slow? We have to look at where 0 is and how far away is the line from 0. But they're on different sides. Yes, but we're looking at how far away they are. So which one is slower, the first part or the second part? How big of the arrow would it be? How big is this arrow compared to each other? The first one is smaller, so that means it's going slower in the beginning. Now you get it? Yeah. All right. Once it starts to fall into place, things start to work together. You're like, okay, so in the beginning, the spacing can't be too far apart. But in the end, it has to be far apart. Okay, how many seconds does this last? 1, 2. 2 seconds, right? And the next one lasts 4 seconds. Well, I'm going to be going, which way am I going in the beginning? Put that in the chat. And then which way am I going afterwards? So first I'm going this way, now I'm going that way. What am I doing? What would I have to do? So you can put in the chat what you're doing. I like how you have different ways to say the same thing. Okay, so we're starting to the left. Looks like everyone agrees that we're going opposite of positive. So on the position time graph, we'd be going down. On this representation, we're going to be going leftward or negative. Great. So we're going to be going negative slowly and then immediately turn around and go fast. So if I'm going to go slow, if I start way over here and I go slow and I turn around and go positive really fast, I'm way off of that chart. So why don't we start, maybe I have to go that way a little bit, so maybe start a little close to 0. We're just kind of planning this out. How far should it go in 1 second? What do we want to call this speed here in terms of our numbers over here? Last time we called it 1. We can call it half, and then we can be closer to 0, and we'll be able to fit the whole thing in. Why don't we call this 1/2? We could call it 1. It doesn't matter. But I'm going to call it 1/2 just to be weird. So this is negative 0.5 meters every second. If I move in 2 seconds, 1 meter, that's what I'm saying, right? In 2 seconds, I'm moving 1 meter. So in 2 seconds, I've moved from here to here. Oops, sorry. In 2 seconds. But this is not 2 seconds. This is only 1 second. This is time 0. This is time 2. I need one right in between. Notice I didn't put numbers on the velocity time graph because we can change it as necessary to make it work. And if you said 1, that's fine. You could start at 2, then 1, then 0. That works. Now, we're not at 0 still. We're going to be turning around, and the next second, we're going to be farther along. So if I was going this way and then suddenly turned around, on the 3rd second, I'm now twice as fast going that way. So where am I back? I was at 0. Where's my next dot have to go? If I'm now going twice as fast as those, where am I back at? Good. Make sure you put units on those. 1 meter. Yes. 1 meter. And since I already have something at 1 meter, I'm going to move it up a little bit. Okay. Thanks. Nice catch, Derek. Okay. So I'm going to keep going that pace for the rest of the time. Stepping 1 meter every second. How did I know that? Because we already said this was 1 unit. This right here is 1 unit of velocity, whatever that was. Maybe it's negative 10. Maybe it's whatever. It doesn't matter. But this one's going to be twice as much. So if that's 45 miles an hour, this is 90 miles an hour, right? The numbers are arbitrary. Okay, so we're going left, some slow speed, and we're going twice as fast to the right. Some of you get hung up on the numbers, and that's totally fine because you've been taught that way in math. Get stuck on the numbers. The numbers matter. They do. But in this case, we're just trying to get that basic general idea of what's happening. We're going to the left. Now we're going to the right, but faster. And because this graph is so high compared to how far below this one was, it's twice as high as this one. So that means it's going twice as fast. Cool. Already you can start to think, hey, I can write this. I can write the description for this. All right. So here's the tricky part with motion maps. I'll show you. I'll zoom in this part. We change direction very quickly. If I were to say that this was moving to the left, I put a little arrow showing it's moving to the left from here. Where do I put the arrow on this dot? Where do I put the arrow on that dot? It's supposed to go, at that point, he's kind of going to the next dot, which is to the right. I need to move the dot. Erase the dot, add a new one right above it. It's still the same position. It's just a little bit more organized so I can connect these two with an arrow. And that last one, we think it's probably doing the same thing, so I'll keep them the same size. Do you see how first, like if you were just given this right here, how do I know where I started? Well, you should be able to get from one dot to the next following the arrows. If I start here, I go this way and I miss the rest of it. If I start here, where my hand is right there, I go this way and I miss those two down there. So I have to start here so that I go this way and then come back and I've hit all the dots. Kind of like a video game, like a little Pac-Man. I have to start at the dot that would allow me to catch all these other dots. All right, you see, be like, ow, 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 ow. Okay, how cool was that? All right, so bingo. You should be able from here, you should be able to write something generic. and then you should be able to do the position time graph. Where were we at 0 seconds? That's our first dot, right? We started our stopwatch, it says 0. Where were we? We were at 1. How long did it take us to get to 0? 1, 2. So at 2, I'm at 0. Connect those two with a straight line. I bet you can finish this. I know I have to go the other way because that's what the dots did, and that's what it says over here in the velocity graph. I have to go the other way. And I can't go the same pace. I got to go twice as fast. So here I only went 1 and 2. To go twice as fast, I have to go 2 and 2. So 2 and 2. There we go. It's basically 1 and 1. All right. I bet you can write that. Which way was it going in the beginning? You said left. How fast was it going? Slow. Constant pace. Then suddenly, to the right or positive, twice as fast. Constant pace. Written, done. All right. If we look at the time, we are a little over than what we should be at. I didn't get to do a breakout room, but I think that's okay because we were really adding it up in the chat. You guys were asking questions. I hope that was where was the synchronous session. Rather than just seeing me say one long thing, you guys were able to change what I said when I said it because you asked me questions and things like that, and that's what I appreciate. All right. So if we finish these two together, I mean, you would just write this right here, and you kind of see the direction this is going. Here's the cool thing. I could have started up here and gone this way. I still have slow and then fast the other way. I could have done something like this, not using the entire graph, but that's the right idea. All of these would be correct. They don't agree on the numbers, but they do agree on the shape. Slight, gentle down, and then steep up, or steeper. Yeah, that's right. You can start anywhere. Because it doesn't say, the velocity graph doesn't tell us where it starts. Right? That's where we have to kind of be a little creative. I first thought maybe over here, but I worked it out. I'm like, oh man, I ran out of room. So I got to put it somewhere. And the nice thing about drawing on Google Slides, you can select those things and move them around. Yeah, I think so. I think it's really cool. So I'm going to show you these next two ones really quick just to kind of make sure you got it. On the Nearpod, I made this a little bit clearer. Like it's going 1 meter every second and then 2 meters every second the other way. That sounds very familiar. But notice it's going first this way and then first positive and then negative. This one over here, first positive, then negative, but it's going positive a different way than the before. This one is going slow at the beginning. What is this one doing at the beginning? Yeah. Okay, good. I appreciate your feedback on the muddy points. If there's something still muddy for you, that's cool. That's called learning, but I don't want it to the point where you're in tears. Okay? Yeah, be careful. It's moving up. It's not speeding up. It's really easy to look at the graph and say you're thinking speed and it's moving up, so you put the words together, but it's not really speeding up. If it was speeding up, it's going to be getting faster and faster and faster. It's going to be going curved like this, right? So I have to look at this graph and say, based on this representation, this graph is supposed to be talking about the same thing. Up on this graph means to the right. Cool beans? My wife hates it when I say that, but anyway. Thank you so much, guys. I have time for questions until about a few minutes before. I'm going to turn on the waiting room in case anyone from period 6 tries to show up. But you guys feel free to hang out. I've got to sign off at 1:20, but you can log out. To complete the lesson today, do the best you can with the new knowledge that you have. Fill in as much as you can on those 4. You want to do it on the Nearpod? Cool. You want to do it on the Google Slides? Cool. You want to do it on a piece of paper, take a picture of it, put it, as long as you show me how you did it on Google Classroom. I can find it in Nearpod, but I can't magically see your paper unless you put it in the classroom, right? Don't email me assignments. Always put them in Google Classroom. Keep it simple. All right. Okay. I'm just kidding. It's extra wide. Maybe say okay. But no, I think that's okay. Cool. I really appreciate you guys. And we have a quiz on Friday. It's going to be something similar to this and maybe a question about if I'm going 2 meters every second, how far do I go in 5 seconds kind of thing. So you should be able to handle that. And then we're going to take a break from velocity. We'll talk about forces. We need those breaks. We need breaks from stuff so that it takes our brain time to figure stuff out. And then when we come back, you're like, how is that hard? I don't get that happens. It happens with math, right? By the time you get to calculus, you're like, I think I understand algebra now. Like, boy. So give your brain some time. That's why you need to sleep too. All right. If you have a question for me, you can put private to the host, the question, and you can kind of wait. You can ask it right here. We're all in the same boat. If you have a personal thing that you need to talk about, then I could do a breakout room or something, but we can just do it through the chat. It's easier. Let me turn on the waiting room. Thanks so much. I hope that was clear for you guys. If you're still confused about something, try to do as many as you can. Yeah, so there's 4 slides, 4 different motions. Again, though, if you get stuck, do what you know. And if you're having trouble about it, put a comment in and I can help you. Fantastic. I'm glad that helped. I have office hours. I mean, I don't really pay attention to those, but I'm always available for you guys. And that's being remote. It's so hard. So that's why I have 4 to 6 set aside for make sure I focus on you and stuff like that. But pretty much anytime I'm available at the computer, chat at me, email me. I will get back to you as soon as I can. Thank you. See you later, Gabriel. Bye, Angel. Bye, Jesus.